Okay, our next problem have was a little strange at first, but if you see something like this, we could view it this way. Derivative of the denominator is 1 over x plus 1. Well, that is exactly what's here. So I have my u prime, and down here I have my u. So that means we automatically have the natural log of the denominator plus a constant. And that's it. Okay, let's do the next one. Okay. Now, the integral of the secant, we haven't seen this one. We know the derivative of the secant is a secant tangent. We know the derivative of the tangent is a secant squared. But we don't really have an antiderivative for the secant as of yet. So here's a little something that you probably never would think of doing, but this is what's going to happen. Okay, and there are actually other ways to arrive at this answer, but we don't have them. We don't have a technique to handle that right now. So here's what we're doing. After this, you'll just memorize the result, but this is how we get it. So multiply the numerator and denominator by this quantity here, secant x plus tangent x. Then notice that the denominator is a secant squared x plus secant x tangent x. And the numerator, I'll just leave it the way it is. Sorry, the denominator. Leave it like that. Now, what do you notice about this? What's the derivative of the denominator? The derivative of a secant is a secant tangent. Here it is. Plus the derivative of the tangent, which is a secant squared. Here it is. So I have derivative of the numerator sitting right here. Derivative of the denominator is sitting right here in the numerator. It is, in other words, u prime over u. So now I can finally write this as the natural log of the secant of x plus the tangent of x plus constant. And that's what we remember from now on. We remember this one. We put this in our repertoire of memorized results, memorized integrals or antiderivatives. Okay.